Now here the first application we have seen, the vehicle is moving along the horizontal curved road. Then what is the need of this banked road? Means what is the meaning of banking of a road? What is the meaning of banking of road? So this is nothing but the arrangement of the road in which the outer edge of the road is elevated through certain angle. Elevated through certain angle. Means if we observe, this is the horizontal road, then suppose this is the outer edge, it is elevated through certain angle. So this outer edge will get shifted here with the inner edge of the road through a certain angle. This arrangement of road, it is called as the banking of road. It is called as the banking of road. Now when we consider about the surface of the curved road are tilted with horizontal with some angle, this arrangement of road is called as the banking of road. So you will get the such a way the definition of this banking of road. So how it is diagrammatically represented and how we can find out the speed of the vehicle in the different situations that we want to discuss here. Okay, so we have seen, so the road, this horizontal road, so now it will get outer edge of the road, it will get shifted through such an angle theta. So you will find the vehicle is now considered here. Now vehicle is considered here, and these are the tire of the vehicle. These are the tire of the vehicle. Again we can consider, suppose this is the point mass, which is like the center of mass. So this vehicle is considered as the single point mass. So you will find the forces which are acting on this vehicle. The forces which are acting on this vehicle, and if we know the forces which are acting on this vehicle, we can find out easily the safe speed of this vehicle when it is on the banked road. When it is on the banked road. So if you observe this diagram, then again you will get idea about that, how many forces are acting here. Now again you will get idea about that, the circular track in this situation, you will find where is the circular track. So suppose this is nothing but, this is the part of the circle, you will find there will be the, suppose like this, the center is considered here. Okay, and now this vehicle is considered here, like the arrangement of this road, like this arrangement of this road, like this. So you will find here, now the vehicle is considered here. Now the vehicle is considered here. This vehicle is considered. Okay, so you will find here again, these are the tires. These are the tires. This is the radius of the circular track. So your vehicle is moving along this way. Along this way. So this vehicle, it is moving in this direction. So you will find, we are interested to find out the velocity, that is the speed of the vehicle when it is moving along this direction. So this is the circular path. This is a track of the circular path. For the simplicity, the diagrammatic representation is shown like this, which is shown here in this diagram. Now when we consider about the forces which are acting in this condition, then first force we know, it is always acting in downward direction, that is weight of the vehicle. means m, it is the mass of the vehicle, and g is the acceleration due to gravity. Secondly, you will find there is a one force which is acting, okay, which is acting perpendicular to the road surface, which is acting perpendicular to the road surface. So you will find here, suppose this is such a way that we can draw this force which is acting perpendicular to the road surface, and this is nothing but the normal reaction. This is nothing but the normal reaction. So in this case, n is the normal reaction which is acting vertically upward, and it is perpendicular to the road surface. See, it is perpendicular to the road surface. Okay. So these are the two forces which are acting here. Now, when we consider about the resolution of this n, so this n it get resolved into two component. The first component is the vertically upward component. It is n cos theta, while theta is angle between these two. Similarly, we can draw the another component which is a horizontal component which is acting in this direction, So if we complete this, then easily we can draw this component which is moving in this direction. I will complete this rectangle so that you will find here this is nothing but the another component which is acting here, and this is the first component which is acting here. Now this component, it is n sin theta, but if you observe this component, then this component is along the center of circle. This component, it is along the center of circle. So here we can write 2 center of circle. So if you observe this direction, it is towards the center of circle. Means you will find this component is acting in this direction. So this is nothing but n sin theta component, okay, which is acting along towards the center of circle. Now if you observe in this diagrammatic representation, then this is the diagram for vehicle on banked road. This is the diagram for vehicle on a banked road. Okay, so you'll find this is the diagrammatic representation, and now we are interested to find out the safest speed of the vehicle when the vehicle is moving along such a type of the inclination theta, and this is the horizontal surface, and this is the inclined road. This is the inclined road, and now vehicle is on this inclined road. So you will get like this, that is different forces are acting on the vehicle, like normal reaction, like mg, and again the third force which is we here not consider, that is the frictional force. Okay, so how we can find out these explanation related to this? So we are interested to find out the safe speed of vehicle. You can observe this diagrammatic representation, you will get the different concepts, and from by using this we can find out this safest speed. Now from the diagram it is very clear that when the vehicle is along the banked road, then you will find the downward component, it will get balanced with the upward component, and this n sin theta, it is towards the center of circle, means we know it is get balanced with CPF. It get balanced with CPF, means the required centripetal force, it is because of the component of this normal reaction. Now we can easily find out the equation from this diagram. You will get the first component, that is n cos theta, it is get balanced with the weight, say this is equation number 1, and second n sin theta, it get balanced with CPF, it is called as the centripetal force, which is equal to mv square upon r, where this v, it is taken as the safe speed of the vehicle. So you will get, these are the two equations. We can say, suppose this is equation number 2. Now if you observe these two equations, then you will find here, this is in terms of sine, this is in terms of cos. So we can take the ratio of 2/1. So if we do the process, that is dividing the equation 2/1, comma, we get. Dividing equation 2/1, comma, we get. So if we take the division of left hand side, n sin theta divided by n cos theta is equal to mv square upon r into mg. So you will get this type of equation, and easily now we can find out the value of v. Okay, so you can remember nn will get cancelled, and here again mm will get cancelled, and sine upon cos, we know it is a tan theta. Sine upon cos, it is a tan theta, which is equal to v square upon rg. And if we take cross multiplication, then you will find here v square is equal to rg tan theta. V square is equal to rg tan theta. And if we take the square root on both sides, then v is equal to under root of rg tan theta. So you will get, this is the important expression for v, and this expression is called as the safe speed of the vehicle when vehicle is considered on banked road. So vehicle is considered on the banked road, and here we have find out the expression for the v, which is called as the safe speed of the vehicle. What is the explanation from this equation? V is equal to under root of rg tan theta. Now if you observe here theta, it is called as the angle of banking. It is called as the angle of banking, or it is banked angle. It is also called as the angle of banking or banked angle. Okay. Then these are, it is the radius of this circular track, g acceleration due to gravity, and this theta, it is a angle of banking, or it is called as the banking angle. It is called as the banking angle. So this is the first expression which we can observe for this safe speed of vehicle. From this relation also we can find out the angle theta. And this angle theta, it is called as banking angle. That is theta. So this is a very simple, if we know the relation for the v, then we can change this relation for theta, means by using that relation we can find out this banking angle, and it is useful for designing a road. So if we consider this term, that is we have taken the squaring of this term, that is banking of angle, that is we know what v square is equal to rg tan theta. Now we are interested to find out this value of theta, so this relation is written as tan theta is equal to v square upon rg, so theta is equal to tan inverse of v square upon rg. So you will get here, this is also the very important relation, very important relation, that is of theta. So you will find here the expression for speed and the expression of, this is a step speed, and the expression for this banking angle, these two are correlated. So you can remember this value of V, it does not depends upon the frictional force. It does not depends upon the frictional force. Okay, so you will get this is the relation, and this is also the relation for theta, which is called as the banking angle. Now we are going to discuss about the maximum and minimum speed of the vehicle. Maximum and minimum speed of the vehicle. Now for to obtain the maximum and minimum speed of the vehicle, that we are going to draw the frictional force, and because of that frictional force we can find out the maximum and the minimum speed. Now here in the safer speed, it is calculated without considering this frictional force which is present between the road and the surface of the tire. See how we can develop this diagrammatic representation for considering the frictional force. So suppose this is the banked road, so this is the, already we have seen theta, which is called as the banking angle, Now we are discussing about the vehicle on a banked road. We are discussing about their maximum and minimum speed of the vehicle. So we can take the help of this diagram, that suppose the vehicle is considered here, and suppose these are the tires. Say this is the single point mass of the vehicle. Already we know the first weight which is acting in a downward direction, so it is shown as mg. Again we know the another force, it is perpendicular to the road surface, and it is the normal reaction. So you can observe this is nothing but the normal reaction. Again we know these normal reactions are get resolved. We can resolve this normal reaction like vertical component and like horizontal component. So if we consider then you can complete this rectangle, due to which you will get idea about this component. So you will find this is the component and this is also the component, and we have completed this resolution. So this is the direction of n, this is the direction of n cos theta. So you will find here again this theta angle is here. So this component is taken as it is n sin theta, and the direction of this n sin theta is again towards the center of circle. This n sin theta component. Okay. Now here we want to consider one more factor, that is the frictional force. Because we know the speed, maximum or minimum speed, it depends upon the frictional force. So how we can show the frictional force? Suppose if we consider this tire, then we know the frictional force is always tangential to the surface. So you'll find here, suppose this is the direction of this Fs, So you'll find there is also the another direction of this Fs which is acting in this direction also. Now out of these two, one is responsible for the maximum speed and another is responsible for the minimum speed. Okay, so we can resolve these two, that is the force of static friction, in terms of sine and cos theta component. Okay, so you will find here, if we resolve this, then one component is in the direction of this centripetal force, which is in the direction of the centripetal force. So if you remember this, then you will find the one component is acting in this direction. This is the one component. Okay, and what will be the another component? Perpendicular to the this. So you will find this is this component which is acting in this direction. Okay, now this component you will find here, again the angle is shown. The angle between these two, it is denoted as, suppose, theta. So the component which is acting in this direction, it will become as Fs cos theta. And the component which is in downward direction, this will become as Fs sin theta. So you will find these are the components which you will find here. Similarly, if we consider this is the force which is acting here, then also we can find out the component. The first component which is acting opposite, which is parallel to this, but which is acting opposite to the direction of this n sin theta. So you will find it is moving in this direction, and another component now we can draw by taking the perpendicular which will act in this direction. So you will find here now the component which is here vertically upward, it is taken as Fs sin theta, and this component you will find now here, it is Fs cos theta. We'll say here Fs cos theta, and this component is denoted as Fs. So you should remember like this, when we want to find out this maximum speed of the vehicle, you have to consider this component which is moving in the direction towards the center of circle. Means n sin theta, it is towards the center of circle. You will find another component of the force of static friction which is acting parallel to this. So we can take the addition of this component with this component which are acting towards the center of circle, so that you can find out the maximum speed. While in case of the minimum speed, we are going to use this component of the frictional force, because this is the component Fs cos theta which is parallel to this direction, but this is pulling towards the center and it is pulling away from the center. So it will pull the vehicle in the back, so it will reduce the speed of the vehicle. So it is considered as the minimum speed of the vehicle. Now here we are interested to find out the expression for the maximum and the minimum speed of the vehicle. See how we can explain the maximum and minimum speed of the vehicle. So we can focus on this diagram so that you will get idea about all the components which are acting on the vehicle, So at the same time we'll discuss about these two expressions, that is the expression for the maximum speed, and expression for the minimum speed. These are very simple for to calculate the maximum and minimum speed of the vehicle. Now when we consider about the maximum speed, you should remember the condition that V, it must be greater or equal to this component Rg tan theta. Now this relation we know, that is the shape speed of the vehicle. या सेफ स्पीड पेक्षा आपलं स्पीड जास्त असणार आहे, सो इट इज कॉल्ड ॲज द मॅक्झिमम स्पीड. अँड फॉर द मिनिमम स्पीड यू विल गेट आयडिया अबाउट दिस स्पीड मस्ट बी लेस दॅन, मीन्स दिस कंडिशन you will find this speed must be less than or equal to this safe speed, that is Rg tan theta. So this is the first very important relation. V must be greater than Rg tan theta or equal the V less than or equal to Rg of tan theta. Similarly here we know the relation, that is mv square upon r. This is the centripetal force. This centripetal force also must be greater than or equal to, this is greater than this component of n sin theta. We know n sin theta, this component is acting along the direction towards the center. It is called as the centripetal force, means centripetal force is greater than this component. What will be the situation here? You will find here mv square upon r, it is less than this component of n sin theta. Now here if we know these are the conditions for to find out the maximum speed and minimum speed, we know the safest speed of the vehicle is given. The safest speed, it is a given v is equal to under root of Rg tan theta. This is the safe speed of the vehicle, and we are interested to find out maximum and minimum speed of the vehicle. Now if you observe this diagrammatic representation, then you will find vehicle is shown here. Okay, the components are shown. Weight is downward, normal reaction perpendicular to road surface, their components are shown. One additional force is considered here as a Fs, that is a static force of friction. Its component are shown like at this surface and at this surface. Okay, so you will find here, first we can find out the maximum speed of the vehicle. We can obtain the equations from this diagrammatic representation, and for the maximum speed we can use this component. It is along the surface but it is acting in downward direction, means we can say it is along the inclination, but downwards. Okay, if you observe this diagrammatic representation, we'll write certain equations. Okay, so you should remember we want to observe this and this. See, this and this for this maximum speed. So see, if you observe here, then n cos theta vertically upward, these two components are vertically downward. Okay, so you should remember this n sin theta, which is addition of these two, and again n sin theta, fs cos theta, they are moving in the same direction but they are towards the center. So the addition of these two is centripetal force. So you will get the two equations and we can solve these equations. Okay, so the first equation I will write from the diagram, that is n cos theta, it is get balanced with mg plus fs sin theta. Say this is equation number 1, because mg and fs sin theta, they are acting along the same road. The secondly you will observe, that is related to the two components. These two components they are along the direction towards the center of circle, so it will get balanced with the centripetal force. Centripetal. So we know this centripetal force, it is get balanced with n sin theta plus fs cos theta. Fs cos theta. So we can put the value here, centripetal force mv square upon r, which is equal to n sin theta plus fs of cos theta. Say this is equation number 2. Now if you observe equation 1 and equation 2, we can make the equation for 1 and 2. That is, we can convert the equation m for mg and the second equation for the mv square upon r. So this equation we can represent like this. Equation for mg, that is mg is equal to n cos theta minus fs sin theta, and we can say, suppose this is equation number 1. So you will get here mv square upon r, n cos theta minus fs sin theta, n sin theta plus fs cos theta. Now we can take dividing equation 2 by 1, so that we can find out the speed. Okay. Now here we can take the explanation like this. Dividing equation 2 by 1, comma, we get dividing equation 2 by 1. So you will find here mv square upon r divided by this mg is equal to, we can take dividation of this n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. So you will find here this mm will get cancelled. You will find here v square upon rg is equal to Now in this relation we are going to divide the n cos theta on the right hand side. For each term we can divide with n cos theta. Okay, so you will find here this is n sin theta divided by n cos theta plus fs of cos theta divided by n of cos theta, then n of cos theta divided by n of cos theta minus fs sin theta divided by n of cos theta. Now we are very close to the expression C. If you consider here, then this first term nn will get cancelled. You will find sin upon cos is tan. Okay, it will get cancelled. You will find a 1. Okay, sin upon cos, it is considered as a tan. Again cos will get cancelled here. Now here we know the one relation, that is again the maximum speed depends upon the frictional force. So when this frictional force is a maximum, we know the relation mu s into n. So you can replace now this fs upon n. It can be get replaced. This fs upon n, it can be get replaced with mu s, which is called as the coefficient of static friction. Okay, so you will get here, that is the next step. So here we are interested to put the values. So v square upon rg is equal to it will become as a tan theta plus it will become as a mu s divided by it will become as a 1 minus it will become as a mu s tan theta. So you will find these are the remaining terms. Tan theta plus mu s divided by 1 minus mu s tan theta. And now directly you will get the relation by shifting Rg to the right hand side. C. So you will get the final relation over here, that is V is equal to under root of Rg in a bracket tan theta plus mu s divided by 1 minus mu s tan theta. So this is very important relation for to find out the maximum speed. So I can write here it is a Vmax. So here also you can write, when we put the value that is a Vmax, we can put here, this is also we can put as Vmax. So you will find here this is the maximum velocity. This is the maximum velocity. So according to from this relation you will get Vmax is equal to under root of Rg tan theta plus mu s divided by 1 minus mu s tan theta. Now similarly we can obtain the expression for the minimum speed, but only difference is that in this expression you will get the sign will get change. Sign will get change. काय साइन चेंज होणार आहे, तर इथं प्लसच्या ऐवजी मायनस येणार आहे आणि इथं मायनसच्या ऐवजी प्लस येणार आहे. ऑल द टर्म्स यू विल फाइंड as the same. Say, let's we discuss and then we will stop. So for the minimum speed of the vehicle we can repeat the same things or the same steps, but in the minimum speed you have to use this component. This component means it is along the inclination but in upwards, so it is considered as upwards. Okay. Now if you observe, then similarly we can write the equations by comparing here for to find out the minimum speed. Say I will write the equation 1 with the help of this diagrammatic representation. You should remember this and this now for the minimum speed. Okay. So if you observe, then I will write what should be the weight. What should be the weight. So if you observe, then you will find now the weight is acting in downward direction and these two are in the same direction. So for minimum speed, from the diagram we can write mg is equal to this n cos theta plus fs of sin theta. Say this is equation number 1. Okay, equation 1. What will be the equation second? Now just you observe. This n sin theta, it is towards the center. This fs cos theta which is in opposite. So वजा चिन्ह आपल्याला इथे घ्यावं लागेल दोघांच्या मध्ये आणि तो सेंट्रिपिटल फोर्स असेल. So we can write here the centripetal force must be equal to n sin theta minus fs of cos theta. Just see, n sin theta it is towards the center of circle, while this component fs cos theta it is pulling back. It will pulling back. It is responsible for to decrease the speed of the vehicle. So you will find centripetal force again mv square upon r is equal to n sin theta minus fs of cos theta. So we can say this is equation number 2. So just compare mg. You will find there is a plus sign. For mv square you will find there is a minus sign. The steps are the same. Again we can take the same thing, dividing equation 2 by 1. Dividing equation 2 by 1. What we can write directly here? See, directly we can write here this v square upon rg. We can consider this terminology. Here instead of plus there will be the minus, and here instead of minus there will be the plus. So you can repeat the same process. You will reach here. you will reach here. Now instead of the maximum, you have to write the minimum. You have to write the minimum. So similarly again, we can use this condition. If the frictional force of maximum, then we can show this relation. We can show this relation. This is very important. So we can write this equation, that is V minimum square divided by Rg, which is equal to, you will find now the difference is that tan theta minus mu s divided by 1 plus mu s of tan theta, and finally the relation which you have, this is V minimum. What will be the V minimum relation then? You will find only the sign will get changed. Rg, it is tan theta minus mu s upon 1 plus mu s of tan theta, and this is very important relation for the minimum speed of the vehicle. So what is the difference between the maximum speed and minimum speed? So we know this is a relation for V minimum, this is a relation for V maximum. If you observe, then maximum and minimum speed, it depends upon this coefficient of static friction, then this theta, that is the banking angle, and again r, that is the radius of the circular path, and g, acceleration due to gravity.